Assalamualaikum. In this presentation, my group will talk about industry revolution about IoT. My name is Muhammad Azwan bin Harun and this is my group members. Let's begin with evolution of industry revolution to understand how we achieve industry 4.0 today. At the beginning, industry 1.0 used steam power to mechanize production. A century later, industry 2.0 began to use electricity to power mass production and assembly lines. After that, Industry 3.0 have electronic and computing to pave the path of software automation. And today, Industry 4.0 have artificial intelligence, Internet of Things, and cyber-connected physical system. So, what is exactly Industry 4.0? At its core is the digital transformation of the manufacturing world. It's the seamless integration of digital technologies like IoT, AI, and big data processing into industrial process to create what we call today smart factories. Companies are so eager to make this transition because of the key benefits. First is efficiency. Connected machine can actually predict their own maintenance needs to drastically reducing downtime. Second is agility. Production line can be changed almost instantly to create customized products. Third is innovation. Company can prototype much faster through digital simulation. And finally, sustainability. Precise data allow for much better resource management and far less waste.
My name is Muhammad Abdullah bin Faizi and I'll continue about IoT fundamental. What is IoT? IoT is a network of smart sensory asset and interconnected device using high precision data collection. The role in Industry 4.0 is act as a foundational communication network that enables decentralized intelligence, and it function by enabling real-time data exchange between machine and system to provide visibility over production. For IoT architecture that consists of 4 layers. The first layer is sensing layer, hardware like sensor and actuator that capture real-world physical data. The second layer is network layer, infrastructure 5G, Wi-Fi, and protocol MQTT and ZigBee that bridge the gap between the floor and the servers. The third layer is processing layer. It uses AI and big data analytics to filter noise and identify trends such as predictive maintenance indicators. And the last layer is application layer, the human-machine interface, providing visual dashboard and decision support for the managers.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mirza Muayyad bin Mazaki, and now I would like to talk about challenges in quality management. First is the high initial investment, which is high upfront cost for hardware and specialized staff training remain a steep climb for smaller firms. Second is the interoperability, which is legacy machine from different era don't talk to modern cloud, creating trapped data silos. Third is the security risk, which is connectivity invites cyber threats like silent manipulation, where hackers subtly alter sensor data to hide defect. And lastly is the data overload, infobesity, which is million of data point cause alert fatigue, meaning data defect get lost in the digital noise. Next is a comparative analysis between traditional SPC and IoT-driven SPC. In data source, the traditional SPC seen to periodic sampling, while IoT SPC are continuous stream. In response time, the traditional have lag factor, while IoT have instantaneous stop-line intervention. And lastly, in risk profile, the traditional have high sampling rates, while IoT eliminates sampling rates.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ian Azur bin Azmi. Today I'm going to present about impact on cost of quality. There's three of impact on cost of quality, which is the first one, which is prevention and appraisal shift to automation, which has two characteristics, which is high sunk costs, reduce appraisal costs. Reduce appraisal costs once installed, the cost to inspect 100% of production become virtually zero. For the second one, which is failure cost, radical reduction. They have two characteristics, which is internal failure and also external failure, recalls and warranty. The third impact on cost of quality, which is a strategic ROI, life cycle perspective, which is got two characteristics. The characteristic, which is waste minimization and also predictive longevity. For the next slide, I'm going to talk about IoT challenges in Malaysia. The first one, which is limited implementation understanding. Many organizations are still unsure how to integrate IoT into their operation, which slows down progress. For the second point, high investment costs. IoT requires significant spending on infrastructure, devices, cybersecurity, making it difficult for smaller businesses to participate. Third, the talent gap and training needs. Overcoming these challenges is essential for Malaysia to fully unlock the benefit of IoT and drive industrial growth.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zamuddin. Now I will talk about quality 4.0 and IoT. First, real-time data collection, which is we monitor 100% of production. Second, proactive defection prevention, which is we use AI to predict and stop error before they occur. The last one is the digital twin in Quality 4.0, which is a virtual mirror of our factory that let us simulate and solve issues safely. Next, I will talk about conclusion. Industry 4.0 integrate physical machinery with advanced digital network to create intelligent cyber physical production environments. At its core, the Internet of Things provide the foundational architecture necessary for decentralized, intelligent, and autonomous operation. By utilizing the real dat- real-time data analytic from sensor to high-level application, this shift enable proactive quality management. Ultimately, this transformation optimize the value chain by reducing waste, ensuring product integrity, and significantly enhancing traceability. That's all from me. Thank you.